Hi friends, in last tutorial we tried to create binary search tree and we implemented insert and display function for displaying the binary search tree. So this was display function and this was the insert function. This was the create BST node and this was for in-order traversal of the tree. Display function is basically using in-order traversal to display the elements of the binary search tree in sorted order. So let me quickly run once to recap what we did last time. Compiled and built BST executable. Let us clear the terminal and now let us execute, and we see that the inserted elements have been displayed in sorted order. So this was what we have done till now. So today we are going to discuss about the delete function, which is little bit complicated, and I had shared last time link which I am following to do the delete operation. So when we insert the elements like this, the binary search tree which we get will look like this. So we have 10 at the top and then 5, 3, 8, left side, left subtree is 7, 6, and right side we have 20, left of 20 is 12, right of 20 is 80 and 90. So this is the binary search tree we will get once we insert all the elements into the tree. Traversing it in the in order, we will get so if we traverse it in the in order traversal, then we will visit 3 first, then 5, then 6, 7, 8, and then 10. Next we will go to 12, 20, 80 and 90. So this way sorted list will get printed. Now we are interested in doing the deletion operation. So here we have different kind of nodes available. For example, in blue, these are the leaf nodes. So they have 0 children. So if we want to delete them, we just have to remove those nodes and make its parent equal to null. Similarly, if we want to delete 6, we have to make its parent left is equal to null, and same for 12 and 100. So that was leaf nodes. Now the second possibility is if one child, left child or right child. For example, let's say 7. So this is a node with one child. This is 8 also is node with one child. And 80 is the node with one child. If we delete 80, if you want to delete 80, then this 20 is right, which was pointing to 80 first. It will now point to the right child of the node getting deleted, which is 100. So this was also a little bit easier case. But the third case is, let me take, let's say, third case is where you have 2 children for the node being deleted. So which are the nodes which have 2 children? They are nothing but 5, 20 and 10. Let's go to the third case where the node getting deleted has 3 children. So this is the same binary search tree which we had. So here these are the 3 nodes which have 2 children, 5, 10 and 20. So first what we'll have to do is find its in order successor. We need to find in order successor. For example, let us consider the case of deletion of node 5. So in order successor of 5 is nothing but the node which comes in sorted order, so it will be 6. So this 6 node will be the in order successor. So when 5 gets deleted, 6 should come in its place. If that happens, then our binary search tree will maintain the property of binary search tree basically. All the left children less than node, and right child nodes will be greater than the node. So that property will be maintained if we in order successor to the place where it is getting deleted. One more thing we need to do will be, we'll have to suppose here uh, 6 is leaf node, but suppose we had something like 6.5 as the right side of the right child of 6. In order successor will be 6, node 6. In that case, what we'll have to do, a left child of 7 which was going to 6, now because 6 is moving to this location, 5's position, we'll have to redirect it to 6.5, that is the right side of the in order successor. So let me write the second step. First we have to find the in order successor. Second, this is nothing but in order successor's parent will be equal to successor. This is in order successor. There is no need to actually delete the node 5. What we can do is just, because everything else will remain as it is, all the links will remain as it is. Only thing we will have to do is copy the contents of node 6, copy the contents of successor, in order successor, into the contents of node getting deleted. We will have binary search tree after deletion of node 5. So this we will free later, and we have now new tree with node 5 being deleted. So if I put 6 here, then we have perfectly a binary search tree. So this is what our binary search tree will look like after deletion of node 5 if there was 6.5. So but currently if 6.5 in our tree it is not there, so it will be, its left will become null. So this is what the deletion logic is, node getting deleted with 2 children. So we'll have to take care of these 3. So these are the cases we need to take care while deleting the node. Node with 0 child, that is leaf node, then node with 1 child, and node with 2 children. So to do these operations, we will require some helper functions. For example, we need to find in order successor. Second helper function can be to find, third can be finding how many children a particular node has. So it can be count children. And one more can be swapping the values. Require one more helper function to find the node which we want to delete, that I can name it as find node. So these are the helper function we need to implement. So let's get started with code. Start with finding node. So find node. It will take argument BST tree, our BST tree. This one, I can say it as BST, comma, the node which we want to find. It will be a straightforward implementation. Let me go to the other. Let's say we are trying to find node 7. So we'll take a pointer pointing to start with the root, then if I'll take it current pointer, our data is less than the current, will traverse to the left. Data is greater than the current node will traverse to the right. Then compare with 5, 7, it is greater than 5, so we'll traverse to the right. Similarly, 7 is less than 8, we'll traverse to the left. And here we have found our node which we are searching for. So let us implement that logic. So initially sanity check I'll do that our tree is not empty. If it is empty, we'll just print and return and data type. Currently I'll keep finding, so we need to return the node pointer to that data. Then if it is not null, create a traversal pointer, let me say current, which should initially point to BST root. Then we will continue this loop if our data till current doesn't go to null. If our data is less than current data, then we need to update current to current left. Else, if data is greater than current data, we will update current to current right. Else our data is matching with current node's data. In that case, we need to return. So for that, we'll have to do a return current, because current is pointing to current data which we are looking for. Statement, a print statement which will for data %d, and I can call it okay. If we find it, it will be printed here. If we don't find it, we need to at the end of the not found, at the end of the while loop. Yeah, I think this looks good. Check if this function works fine. Let me try to find a node and b1 comma, let's say 7, the one which we checked. Let us compile and run. So if no value, we need to return null. So I'll go to 66 and say if not found, we need to return null. Sorry, if tree is empty, we need to return null. So yeah, compilation successful. Let me run it. And yes, we have got the message found data for node for data 7. Now that we have written the find node function, so we have completed this find node. Let's go to the next, let's say in order successor. Let's try to write in order successor. So if we see the tree here, let's say we need to find in order successor of 5. So for that we need to take right and then we have to go left till we reach the null. So then 6 will become our in order successor. It will take BST node as the argument, and it will return the address of the node which is the successor. Let me take a temporary pointer which will point to current node. I have to take a right, and then if temp points right is not null, then temp will be equal to temp right, and then we have to traverse left till we reach null. So then we need to move, we need to check temp left. If not null, then we need to keep moving temp equal to temp points left. So when temp left reaches null, that is the node which will be the in order successor for the given node. So after that we'll just return temp. But this while should come inside the if statement. Now let's try to write count third function. Maybe we can write count children will write. That's easy. So it should return number of children. So count children for any given BST node. So we can take one variable count. Initially we can keep it 0 if node if left node left children is there, we will do count plus plus. If node right is there, then also we'll do count plus plus. Yeah, that's all. After that we'll just return count. Next we can plan to write find parent. Now find parent will be almost same like find node, except we will keep a parent pointer to keep track of the parent of given node, current node. So let me just copy paste find node and make it find parent. Find parent basically of a given node. Arguments will be the tree and the data whose parent we need to find. So here we'll have to use one more pointer that we can call it parent. Initially it will be null. Well, if you want to go left, right, or it's matching. If it goes left, okay, we need to use braces. Here, when we are updating current pointer, we have to update parent as well. So parent will be and current will get updated to the either left or the right. Here also parent will be equal to current. So this and in the end we need to return parent. In the end, when we find the element, we need to return parent instead of current. And let me comment it. Or we can update it. Yeah, let me comment it. If node is not found, we can return null. Now that we have written all the functions, skip swap for now. It is just copying data from in order successor to the node getting deleted. Let's get started with writing delete function. It will be BST tree and then node getting deleted, and we need to initially sanity check. We can do that tree is not null, and then we need to handle three cases. If we need to find the children, before that bst node star. We need to find the node which we want to delete and find out how many children it has. So I can say current equal to find node, and let's pass data to it. And then we need to find how many children it has. Count children, current. Obviously we need to check if current is not null. So okay, if current is not null, then only we need to update the children. Here I can keep declaration children equal to 0 initially. Then we need to find out how many children this current node has. So let me write it as node instead of current, so it will give better readability. Now once we know how many children it has, we have to handle the case. Here I need to pass bst. Yeah, we need to handle 3 cases. If children equal to 0, one set of operation, else if children is equal to 1, the other deletion operation, else that will be the third case, nothing but node with 2 children. Now let's go to the tree and see when we are deleting node with 0 children, for example 3, 6 or 100 or 12, what we have to do is this will be the node getting deleted and this will be its parent. So we will have to do parents left as null and delete node. Similarly, if 8 is getting deleted, we need to make parents right equal to null and delete this node. So let's try to code it. Let me take a temporary variable, temporary pointer, which will point to node which we need to delete, so that we can use a temp variable to free the memory. Now we need to check if we need to get parent as well, right? So let's write find parent of bst. Find parent bst, basically tree bst comma data which we need to, whose parent we need to find, and let's take it in a variable bst node star parent, and then we need to check if it is left child or the right child. So if parent left is equal to node, that is node is left child which is getting deleted, then we need to make parents left equal to null, else it is the right child which is getting deleted, so we'll have to do parents right equal to null. So let's run this and see if we can delete leaf nodes. Let's compile, return null, 130 line. So yeah, here we just have to return no null value. Yeah, it has compiled. Let me run it now. but we need to delete some element at the end, right? Let me comment out find node, and let us delete one of the leaf node. For example, let's say 12. So after deletion, we need to display the elements. So let me compile once again. Now let us run BST. So before deletion, tree was elements were like this, and after deletion, these are the elements. And as we can see, 12 has been deleted, element 12. Now let's go to the case where we are trying to delete node with one children. So this finding parent we need to do for all the cases. So let me just take it out. Let me take it out, the statement, and keep it outside. We know the node, so we need to find the parent. Okay, I'll use this parent in all the conditions. So if we these are the 7, 8 or 80, these are the nodes with one children. So we have to check if nodes left is not null, and if it is not null, then we need to assign it to the node. If it is left side of the left child of the parent, then left, otherwise right. Again to the we need to free the temp which we had used the node to be deleted, otherwise it will cause memory leak. So free temp. Now we are in the second condition with one children. So here also temp is equal to bst node. Then we need to check if parent left. If node is parent's left side, then we need to check the node getting deleted, whether it has a left or right child. So that will be node points left. If it is not null, then we need to assign parents left will be equal to node left. Else parent left will be node right, and after that free temp. If the node is not parents left, if it is parents right, this will be the case. Else we will come here, then parents right, yeah. Then we need to again check if nodes left is not null, then it will be same, but now we need to assign to parents right, because node is parents right. Nodes left goes to parents right, else nodes right goes to parents right. So now after this we need to free. So let me free it here, free temp. Let me delete the above temp free statement. Now let us try to run the program and see if it works fine. Let's compile first. Yeah, successful. Now I need to change the deletes. Delete, let us delete a node which has one child. Let's say I'm deleting 7. We need to compile again. And if we see element 7 has been deleted from the list. Let us try to delete 8 and see. Yeah, if you see here, element 8 has been deleted. So that was the case where we delete node with one child. Now we need to go to the case where we have node with 2 children, which should be deleted. Let's move to the case where we need to handle node deletion where a node has 2 children. So for example, here we can consider deletion of node, let's say 5. So our steps will be first we need to find the in order successor of 5, that will be 6. After that we need to splice. Currently in this tree we don't have right hand side anything, but if right hand side node tree is there, we need to connect it to the successor's parent, left side of successor's parent. That will be a second step. We need to see if successor's right side is not null. We need to make it as parents left, right. Successor's right will become parents left. This will be the second step. And the third step will be to swap the values 6 with 5. 6 should be copied into the node to be deleted. And we are not going to actually delete this node. We are just copying data from this node in order successor into the node which we want to delete. So this will become 6, and we will free this node, and this will be our modified tree. So third step will be to swap data, successor data, node to be deleted data, nodes data. So let's get started to write the code for that. So first I need to find the successor of the node. So I can call it successor equal to, in successor we have written the function, and we need to pass the node as argument. So its successor it will try to find out. Once the successor has been found out, we need successor's parent as well. For that I'll use successor parent. For parent, we have find parent function, which takes argument bst and data. So it will be bst comma data is nothing but successor's data, because we need to find successor's parent. Once we have successor's parent, we need to check if successor has right hand side. If successor's right child is not null, then we need to assign it to successor parent. It will be left or right, because we have found out in order successor, it is always supposed to be the left side of the parent. It can't be right side, otherwise it will not be in order successor. So to parent, we will assign successor's right child. Else there is no successor's right side, so in that case we'll make it null. So successor parent will make it null. So we have completed right hand side of node in order successor to its parent. Now third step is to copy the data from successor to the node getting deleted. So node data will be equal to in successor, or I can say successor, or we can update it to in successor. Anything is fine, just in successor is already function name, so I'll just keep it successor. So we are assigning successor's data to node data, and we need to free that node. So for that, again, I'll use a temp node, and we need to, and this time it is not the node which is getting deleted, it has to be successor. So let me update temp to or I can say directly, yeah, here I can update temp is equal to successor, and then I need to free the temp. Now let's try to run the program and see if it works fine. Let us compile, and then okay. So before that I need to change the element which we are deleting. So here I was deleting 8. Let me change it to 5 and see. Let's compile once again. Now let's run it. And if we see the elements 3, yeah, if you see here 5 was present and now 5 has been deleted. In this code, maybe corner cases might not have been covered. Some error cases, the code may not be working. But overall, this is the gist of how we do deletion operation on the binary search tree. I hope this will help you to understand how deletion works in binary search tree. That's all. Thank you. If you are liking the content, please hit subscribe button and like the video. The link of the code I will share in the description below. Thank you so much.